So here's an example from the lecture notes where a supervisor is choosing between 3 males, these 3 here, and 3 females, and she is trying to form a group of 2 individuals. So we want to be able to select from these groups 2 individuals and think about how many different ways there's to do so. So if we think about the way to choose is if we define the probability that y equals 0, this is equal to, of the 3 men choosing 2, and of the 3 women choosing 0. And this will be divided by the total number of ways in which you can choose a group of 2, which would be 6 choose 2. So this would be 1 times 3 divided by 15, or 1/5, which is 0.2. Well, if we look at the probability that y equals 1, which means we have 1 woman chosen, this is equal of the group of 3 men, we're only choosing 1, and from the group of 3 women, we're only choosing 1, divided by the total number of possibilities to choose 2 people, and that's 6 choose 2. So this will equal 3 times 3 over 15, or 3/5 equals 0.6. Now lastly, we can have the probability that 2 women are on the team, and this is of the group of 3 men, we choose 0, and of the group of 3 women, we choose 2. Over 6 choose 2, the total number of possibilities. And this is similar to the first one, where now we get 3 times 1 over 15, or 1/5, and 0.2. Now, one thing that's key is we want to be able to check our work. So 0.2 plus 0.6 plus 0.2, that should equal 1, and it does. So we are on the road to a probability. Now let's go ahead and write this out in a slightly different way. We can say that the probability that big Y equals little y is equal to, and this might look a little more familiar, 0.2 if y equals 0, 0.6 if y equals 1, and 0.2 if y equals 2. And so that's how we can write out the distribution of this discrete variable based off of this information here. Now let's take it a step further. Let's ask ourselves, what is the expected value of y? Well, this we can then set up by using the equation that we have, where we sum up over the values of y times the probability that y equals y. Well, in this case, and again, I'm going to put that in a box because that's an important equation that we have used and will continue to use. This is equal to y can equal 0 with a probability of 0.2, plus y can equal 1 with a probability of 0.6, plus y can equal 2 with a probability of 0.2. And that is equal to 1. So what do I expect the number of women in this group of 2 to be? I would expect it to be 1. So there's our final answer there. Next, I can ask what's the variance of y? Well, this is equal to the expected value of y squared minus the expected value of y quantity squared. That's a key equation for the variance. I can then just break this apart by first looking at the expected value of y squared is equal to 0 squared times 0.2 plus 1 squared times 0.6 plus 2 squared times 0.2. And this is equal to 7/5. Therefore, the variance of y is equal to 7/5 minus 1 squared, and that will equal 0.4. So there's my answer for the variance. So this is an example where we can take a scenario where we actually are choosing different options and calculate the probability distribution function here, and then from there, calculating the expected value and the variance of that distribution.